Lesson 5.2 deals with parallel and perpendicular lines. So we're going to go ahead and fill in some blanks. And the first one is blank lines are in a plane that never meet, such as the lines that mark the lanes in the sprinting race over here. And those kind of lines are parallel lines. So we know parallel lines are lines that never meet. If we look at this picture down here, it says the top and bottom sides of a window are also parallel. So we've got these top and bottom sides, they're all parallel. However, the left or the right side and the bottom of the window, so right in here, these corners, and where they meet in the middle, they are perpendicular. And we've gone over this before, but perpendicular lines are lines that intersect, come together at 90-degree angles. A blank is a line that intersects two or more lines that lie in the same plane, and that is a transversal. So a transversal is a line that intersects two or more lines. So we can see the sides of the windows are transversals. Right here, these intersect two or more lines. So they're transversals. Okay, so parallel lines never meet, perpendicular lines intersect at 90 degrees, and transversals, or a transversal is a line that intersects two or more lines. Alright, we have right here two lines that are parallel, and they are intersected by this transversal. It doesn't appear that we have any perpendicular lines, but the first thing they want us to do, and I'm just going to demonstrate this, is they want us to go ahead and measure these angles. So I'm going to measure first angle 2, my handy little measurer here, and angle 2 looks like it's approximately 120 degrees. So down here it's showing me that, and then I'm just going to move my protractor around to show you that angle 6 is the same. If I rotate it, then I can show you that angle 3 is the same and angle 7 is the same. So all of those angles, 2, 6, 7, and 3 are all 120 degrees. I don't really have to measure 1, 4, 5, and 8 because of what we learned yesterday. If angle 2 is 120 degrees, then I know that angle 1 has to be 60 degrees because they are supplementary. They form this straight angle right here. And I know that angle 1 and angle 4 are vertical angles. So that's also 60 degrees. We already commented that this was 120 degrees. And I know from measuring that angle 6 was 120 degrees, and I didn't really have to measure. I know that angle 7 is 120 because they're vertical. 6 and 8 form supplementary pairs, so 8 is also 60 degrees, and 5 and 8 are vertical, so that is also 60 degrees. So they're showing you nicely with these different colors down here, the ones that are congruent. We don't generally shade them with colors when we have our own diagram. What we would do is I would show with one little arc that angle 1 and 4 are congruent. Angle 4 and 5, I'm having the same amount of marks, and 5 and 8. To show the difference between, for angle 2, I would use two little arcs, and then 2 and 3 are congruent, and then 6 and 7. So that's how we would show it if we don't have access to numbers. I mean, not numbers, colors. Okay, here it says we have some pairs of the 8 angles that are formed by two parallel lines, and transversals have special names. So these angles right here, let me go ahead and renumber this, and I want you to put your numbers in there as well. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So again, they're showing you the colors. Angle 4 and angle 5 are called alternate interior. Alternate interior. Alternate, I always think is one is on the top, one is on the bottom, and they're inside, so write this down, the parallel lines. and they are on opposite sides, so maybe that's why you can say alternate. Two opposite sides of the transversal. And they alternate. One's on top, one's on bottom. So 4 and 5 are alternate interior. 5 and 6 are alternate interior. And they happen to be congruent. And we saw that from back here that they were congruent. We also have alternate exteriors. So they are outside the parallel lines. And again, they are still on opposite sides of the transversal. So 1 and 8, 2 and 7. So these are called alternate exteriors. And again, we can see by the color coding here that they are congruent. And then we have corresponding angles. They're in the same relative location to each parallel line, and they're on the same side of the transversal. So 1 and 5, they are both on what appears to be the left side of the transversal. 1 is sitting above the first line, 5 is sitting above the second line. And then we have 2 and 6. They are both what appears to be on the right side of the transversal. And 2 is above the line, 6 is above its line. Then we have 4 and 8. Again, they are both on the right side of the transversal, but 4 is below the line and 8 is below its line. And then finally you have 5 and 7. 3 and 7, sorry. 3 and 7. They are both on the left side of the transversal and they're both below their particular line. Alright, so here we go. We have properties of transversals to parallel lines. If two parallel lines are intersected by a transversal, then we have the following things that are true. Corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. So I showed you that before. Alternate interiors are congruent, alternate exteriors are congruent, and corresponding angles are congruent. And that's if we have two parallel lines. This doesn't work though if the lines are not parallel, so this has to be a given. If the transversal is perpendicular to the parallel lines, then all of them formed are right angles. So let's look at something like that real quick. So if I have my two parallel lines, and if my transversal was intersecting at a right angle, so perpendicular, all 8 of these angles would be right angles, and that's what that is saying. Alright, so let's go ahead and start filling in our angle measures here. So here they're telling us that line M and line L are parallel. This is, and I want you to write this down, this is the symbol for parallel lines. So it's two vertical lines. They sort of look like train tracks. And we went over before, when we did our Pythagorean theorem, this is the symbol for perpendicular. Sometimes you'll see it without the right angle in the corner. So both of these work. Okay, so we know that this angle right here is 142 degrees, and we're looking for angle 1. Well, angle 1 and this angle are supplements, so I can take the 142 and subtract it from, I need to put the 180 on top. 180 minus 142 gives me 38 degrees. And it says justify, and I would write that those two angles are supplements. So supplements. So I'm going to fill this in just like I did with the other ones, so 38 degrees. Now I know that angle 1 and angle 3, oops, I guess I should look and see what they're asking me. They're asking me for angle 2. Well, angle 2 and this angle right here are vertical angles, so it's going to be 142 degrees, and I can just put vertical angles. So I'm going to use a different color. So 142 degrees. Then they're asking me for angle 5. Well, I'm going to think about what I know about parallel lines now. I know angle 1 is 38 degrees, and angle 1 is related to angle 5 because they're both on the same side of the transversal. They're both appearing to be above the line. So this is also 38 degrees because they are corresponding angles. So that was 38 degrees. Then they're asking me about angle 6. Well, I could say the same thing. With this 142 degrees and angle 6, they are also corresponding angles. Now, this is not the only reason you could give. You could say that angle 2 and angle 6 are alternate interior angles. They're on opposite sides of the transversal. One is sitting below its line, one is sitting above its line. So you could say alternate interior, or we could use corresponding angles again. It doesn't matter to me which one you use because both of them are right. So I will put down both of them. Corresponding angles or alternate interior angles. Angle 8, I like vertical angles if I can use them, so I'm just going to say angle 8 is 142 degrees because of vertical angles. So this was 142 degrees as well. And then finally, I've got a big old mess here, but angle 7, angle 7 and angle, I can't see it, I think it's angle 5 now, I've covered it up. These two angles are vertical. I could use that, but let me go ahead and think outside the box a little bit. I'm going to use angle 1 and angle 7, so I still know that it's 38 degrees. And angle 1 and angle 7 are alternate exterior angles. And again, I don't care what rule you use as long as it is correct. So you need to make sure that you use a correct rule, but you could have more than one possible answer for this. All right, that is it as far as the notes go. And I do not have an assignment for this yet, so if you check the website, I will have an assignment posted either on the calendar or on my web page so that you can start it ahead of time if you so choose.